do we calculate the nuclear density? So nuclear density is calculated by using the same theorem of rho equals mass over volume. This is a capital V, so I'm going to denote it with a flick here. So mass over volume. So in Euclidean terms, we have to assume whatever the mass may be, but the volume would be spherical, because we assume the atom to be Euclidean, and so we want it to be spherical, and so we'll use the formulaic relationship of the volumetric analysis for the sphere, a hollow sphere. So the moment of inertia for that sphere would be the hollow sphere moment of inertia calculational analysis, formulaic derivation. So just on the side, the units of moment of inertia are kg per meter squared, kg meter squared, and it's separate for a rod, for a hollow rod, for a sphere or a hollow sphere, for a disc, or for a disc, for a hollow, for a disc in the with no center and stuff like that. So it's different. Moment of inertia is different, but in terms of volume, you'll have to use the formula that you use for calculating the sphere. So you'll have to use, yeah. But we know that the way we calculate the radius of an atom is so we'll have to use this here. So we'll have to use this here, okay? So I'll just plug this in and I'll get this one, and then it will be A, because of, I've cubed it so it comes out in its natural form. So it'll be 3m 4 pi cubed atomic number. So this is how things are. Let me use a red marker. So that's how things will be. Nuclear density would be the same as mass per unit volume, right? And then you put the mass here, and then the mass will be in atomic units. AU. And then you'll have 4 over pi, 3 pi, 4/3 pi r cubed, but you'll be using this one over here. And then you'll plug that in to get this 3m over 4 pi r cubed A in atomic unit. This is how things are. You have to be quite, you have to remember to find your way back and forth to formulaic substitution, because most of the times they'll give you the nuclear density, they'll give you this and this, and then they'll ask you to find the mass, and from the mass they'll ask you to specifically find the atomic number or the nucleon number. That's how things are. So they can twist the question in any way, shape or form. Now we will just quickly look at the this formula. R naught, and it'll be cubed. Now most of the times it's written as like this, because people might assume that it's R naught cubed. So to avoid the confusion, it's written in this manner. Right, so this is the femtometric averaged out radius, and then you multiply with the cube of 1/3 of the atomic number, and that's how you get it. Now, if you plotted a graph of this and this, the gradient would be this, and the gradient in this case would be calculated as y subscript 2 minus y subscript 1, x subscript 2 minus x subscript 1, and then it'll be so it'll be r2 minus r1 over a1 third 2 a1 third 1. Make sure you write all of this elucidated before you in the exam as well. So this is what will get you good marks. So r2 minus r1 over a1 third, a third, a to the power third, 2 minus a to the power third 1, and that's so it'll be in femtometers. So that's, you know, it's quite, it works itself out. It's not too it's not as complex as the governmental infrastructure. It's self-explanatory in it, and it can come out very easily if you know your way around formulaic substitution, and if you are well read, you'll be able to connect and link formulae together. Okay, sorry, hang on. Then now okay, so that's the nuclear density. We've done that, and now we'll look at the different types of, so we've got alpha decay, we've got beta minus, which is the normal one, and we've got beta plus, which is the opposite. It's not positron. Now, beta positive is not electron, yeah, it's not positron. Please remember that it's not positron. Okay, this is a misconception you need to root out. And then you've got alpha, beta minus, beta plus, you've got neutron capture, you've got proton emission, you've got electron capture, and then you've got proton capture. It's very hard. Proton capture, I'll write it here, but it's very hard. I'm not going to go there because it requires a lot of energy and budget. So it's very, very hard. So we've got 1, 2, 3, 4, 5, 6, 7. So 7 kinds, and that's how things are. Yep, there we go. Alright, and I hope this helped, and I hope we all learned something today.